Well, hi again everyone. In this video we're going to do some practice problems from chapter 10. So the first one I'm going to talk through is exercise 10-1 in your textbook. Determination of some direct materials variances here. So that exercise said Bandar makes some sporting equipment, and one of the things they make is a football helmet for the North American market, and it takes a special plastic, this raw material. So during the quarter end June 30, the company manufactured 35,000 helmets using 22,500 kilograms of plastic, and that plastic cost in total $171,000. We also know that according to the standard cost card, each helmet should require 0.6 kilograms of plastic at a cost, again that's standard cost, of $8 per kilogram. So the first requirement is to determine the standard quantity of kilograms of plastic, the SQ, that's allowed to make 35,000 helmets. So standard quantity for 35,000 helmets is just going to be the 0.6 kilograms that should be required for each helmet times the 35,000 helmets, or 21,000 kilograms in total. Requirement 2 said, well, what's the standard materials cost allowed? So that's the SQ times SP to make 35,000 helmets. And if we think about it in terms of our overall variance analysis framework, we'd be looking at sort of that far right column, right? The standard quantity times the standard price, which was essentially our flex budget. So here, that's the 21,000 kilograms. And that stuff we were told had a standard cost of $8 per kilogram. So the standard by the standard would be $168,000. Another thing that's worth pointing out here is at this level, and then everything sort of moving to the left when we think of our as-if budget and our actual results, should be at the actual level of activity. Now here we didn't know how many helmets we expected to make before the period, so it becomes a moot point. But if we did have some information about that, we'd want to make sure we were just considering the actual level of output, and then we'll worry about what changes in terms of inputs. So going back to our problem here, requirement 3 is we're looking for the materials spending variance. Now remember, the spending variance is comparing the flex budget, or what would be in the flex budget, to those actual results, which would essentially be the actual quantity and the actual price if we were thinking about those components separately. But here we know the plastic cost a total of $171,000, so we don't have to worry about the individual components yet. So that overall spending variance, again, we're comparing the actual result, the $171,000, to what would be in that flex budget, the $168,000. So just to be explicit, 171 minus the 168, that's $3,000, and because the actual spend is greater than what would be in the flex budget, what we should have spent, we'd say that's an unfavorable spending variance. Thinking about our chapter 10 concepts, that overall spending variance now is going to consist of both the price variance and the quantity variance, those lower level variances. And that's what we're looking for in requirement 4. What's the materials price variance and the materials quantity variance? So one thing we can do is stick in what we said in the notes was our as-if budget. And again, that's at our actual level of output, but that's our actual quantity of input times the standard price. That way we can isolate differences in quantity on this side, the AQ versus the SQ, since the SP is the same. And we can isolate differences in price on this side. The AQs are the same, the AP and the SP, there's our difference in price. So let's start over here with determining what our as-if budget would say. So our actual quantity times our standard price. So we used 22,500 kilograms of plastic. That's our actual quantity for that actual level of output. And then we know that that standard price, that stuff should cost $8 per kilogram. So our actual quantity times our standard price, 180,000. So let's go ahead and find our two lower level variances here. Over here on this side, we've got our 180,000 in the as if minus the 168 from the would-be flex budget. That's a difference of 12,000. Again, the as if is greater than the flex, so we'd say that's unfavorable, and that's our quantity variance. Right? Again, that's the difference in total spend that's caused by a difference in the Q's, the quantity of the plastic we've used in this case. Now, given that we have our quantity variance and our overall spending variance, we could find the price variance just by determining the other portion, if you will, of that higher level variance. But let's go ahead and use the numbers we've determined up here to make that calculation this time. So 180,000 in the as if minus 171 in the actual result means a $9,000 difference. The actual is lower than the as if, so we'd say that's a favorable variance. Again, this is our price variance. So as we can see here, if we netted these two lower level variances together, we'd have a $9,000 favorable price variance, $12,000 unfavorable quantity variance, so in total that's a $3,000 unfavorable spending variance. And then let's just remind ourselves what these lower level variances mean. I was $9,000 favorable in terms of a price variance. So this plastic cost me less than it should have or than I expected it to coming into the period. Right? Some kind of change in the price of that input. Got a discount from the supplier, whatever the case may be. On the other hand, I had an unfavorable variance related to quantity. So I used more plastic than I should have to make these 35,000 helmets. So maybe I had some waste, or maybe I had to make an interim change to add additional material to make them somehow safer, and we hadn't had a chance to account for that in this period, or some other difference related again to that usage of the amount of plastic needed. And that's it for exercise 10.1. Okay, let's take a look actually at exercise 10.2 right after that one and talk about some labor variances. So Sky Chefs prepares in-flight meals for a number of major airlines. One of their products is this grilled salmon. During the most recent week, the company prepared 4,000 of those meals using 960 direct labor hours. The company paid its direct labor workers a total of $19,200 or $20 per hour. According to the standard cost card, it should require 0.25 labor hours at a cost of $19.75 per hour. So before we start talking about some of these calculations, I did want to remind us that some of these variances, at least in terms of their direction, should be a little bit intuitive at a first glance. And what I mean by that is we know that the company paid its direct labor workers $20 per hour on average for this direct labor in this period. But we know from the standard cost card that we thought that labor should cost $19.75 per hour. So our rate variance, we know right off the bat, is going to be unfavorable. We paid more per hour than we thought we should have or were going to. So just something to keep in mind as we talk about variances. Sometimes we kind of have those built-in checks to think about what direction should it be going, or is this favorable or unfavorable. So in any event, let's look at the standard labor hours now allowed to prepare 4,000 meals. So that's going to be equivalent to the 0.25 direct labor hours that it should take to do one meal, 15 minutes in other words, times the 4,000 meals that were prepared. So the standard hours is 1,000. Part 2 said, well, what's the standard labor cost allowed? And again, if we think about our overall variance analysis framework, that's really on the kind of flex budget side over here, the standard hours and the standard rate. So standard hours we just determined to be 1,000 times that standard rate. We thought this should be $19.75 per hour. So there's $19,750. Part 3 asks what the labor spending variances is. So remember, the spending variance is going to be that higher level variance. It's going to come from comparing our actual results over here, so our actual hours and our actual rate, We know that the sum or the product of those things is $19,200, so we didn't have to do the interim math there, though we do know it was $20 per hour. So our overall spending variance is going to be the $19,750 from what amounts to our flex budget minus the $19,200 from our actual result. And here the actual result is less than that flex, what it should have been, so we'd say that's a favorable spending variance. Part 4 asked us to find the labor rate variance and the efficiency variance. So we're going to need our as-if type budget in the middle here, and that's our actual hours times our standard rate. Here we knew the actual hours were 960 based on what was given. That standard rate again was the $19.75 per hour rate that was projected before the period started. There's a total of $18,960. So if we isolate the difference between these two, we're looking at differences caused by the change, if you will, in hours, standard hours versus actual hours. So that would be our efficiency variance. So let's get a number for that. 19,750 minus the 18,960, or $790. And the as-if is lower than the flex, so we'd say that's a favorable variance. Again, this was our efficiency variance. Make sure we label it. And then over here on this side, again, we're isolating the change caused by a difference in rates, the actual rate versus that standard rate. So the total of 19,200 in our actual result minus the 18,960 in our as-if. Again, this is our rate variance. It's $240. Because the actual is greater than the as-if, we'd say that's an unfavorable variance. And again, that lines up with what we spoke of at the very beginning of the problem. We paid folks on average $20 per hour. We thought we were going to be paying them $19.75 per hour. So yeah, we'd expect that to be unfavorable. And we could think about the same thing in terms of efficiency. 960 labor hours is what we actually had folks working to prepare meals. The standard hours were 1,000, so that efficiency variance is going to be favorable. We used less hours than we thought we would. Again, that spending variance is going to be the combination of our two lower level variances. So the $790 favorable efficiency variance minus, if you will, the $240 unfavorable rate variance would also equal this $550 favorable spending variance. And that's it for exercise 10.2. I did want to take a look at exercise 10.3 as well, variable overhead variances. Again, I know there's a lot of similarities with these different variances, but I think it's helpful to work through each one separately just to make sure everything sticking as it should. So 10.3 said logistics solutions provides order fulfillment services, etc., etc. In the most recent month, 120,000 items were shipped to customers using 2,300 direct labor hours. The company incurred a total of $7,360 in variable overhead costs. According to the company's standards, 0.02 direct labor hours are required to fulfill an order for one item, and the variable overhead rate is $325 per direct labor hour. One other thing to point out that I'd skipped was that the company uses a predetermined variable overhead rate based on, of course, direct labor hours. So the first item said, what's the standard labor hours allowed to ship 120,000 items? So standard hours, we know we're shipping 120,000 items, and we think on average, or that should take 0.02 labor hours per item to fill these orders. So our standard hours for that actual quantity is 2,400 hours. Number 2 said, what's the standard variable overhead cost allowed? So the standard hours times the standard rate to ship these 120,000 items. So again, we're over here thinking about basically our flex budget, standard hours, standard rate. We just found the standard hours at 2,400. We know that that standard rate per hour is the 325 that I'm hovering over at this point. So multiply that by the 2400. And our flex budget item, our standard hours, standard rate, $7,800. Number 3 said, what's the variable overhead spending variance? Again, we'd be comparing the flex to essentially the actual hours, actual rate. Although again, here we know that we incurred a total of $7,360 in variable overhead costs, so we don't have to do that interim math yet. Our overall spending variance then is going to come from comparing those two items as shown. So the $7,800 from the flex, based on our standards, minus the $7,360 actual spend, means a $440 variance. Actual is less than flex, so that's a favorable spending variance. We spent less than we quote-unquote should have. That's a good thing, all else equal. Part 4 then wanted to know the overhead rate variance and the overhead efficiency variance. So we're going to need our as-if stuck in the middle here. That's our actual hours, our standard rate, again, so we can isolate the change or difference in hours over here. That will speak to efficiency. And we can isolate the difference in rates over here, and that'll speak to that rate variance. So our actual hours used were 2,300 because we had shipped 120,000 items using 2,300 direct labor hours, times that standard rate, which we said earlier was $3.25 per hour. So our total as-if budget would show $7,475. So the difference on this side, 7,800 minus the 7,475, that's $325. Since the as-if is less than that flex or the standard, we'd say that's a favorable variance. And again, this is our efficiency variance since we've isolated differences caused by differences in the hours used. Over on this side, we've got the 7,475 in the as-if minus the 7,360 in the actual for a difference of 115. The actual is lower than the as-if, so we'd say that's a favorable variance as well. Again, this is our rate variance because it comes about because of differences in the rates alone, right? The actual rate here compared to the standard rate here. Okay, so in other words, our actual rate was less than that 325 per direct labor hour that was expected. And to circle back, our efficiency variance was favorable. We used fewer hours, direct labor hours, than we thought we should have. Right? And we can see that in the numbers. We used 2,300 actual direct labor hours. The standard was 2,400 hours. So yeah, we'd expect a favorable efficiency variance there. Used fewer hours than we thought we were going to or should. Again, if we combine these, they're both favorable, so we can add them together. 325 plus 115 equals 440. Those combined equate to our spending variance. We could also find that, as we did earlier, comparing the flex, the 7,800 based on standards, to our actual spend of $7,360. And that's it for exercise 10.3. Okay, let's switch things up a bit here and take a look at exercise 10.5. We're going to work backwards from labor variances. I think these types of problems can be pretty helpful once we've thought about some of the fundamentals of this variance analysis. So we can sort of work in both directions to make sure we're clear on how these things are derived and what they mean. So here in 10.5, we're told that the auto repair shop of Quality Motor uses standards to control labor time and labor cost. The standard labor cost for a tune-up is shown here. It should take 2.5 hours at a rate of $25 per hour for a total standard cost of $62.50. The record showing the time spent in the shop last week on tune-ups has been lost, but the shop supervisor recalls that 50 tune-ups were completed during the week. The controller also recalls somehow from his or her records the following variance data was found for tune-ups. So we had a rate variance of $150, and that was favorable. and then we had a spending variance of $200, and that was unfavorable. So we want to determine the number of actual labor hours spent on tune-ups, and we want to determine the actual hourly rate of pay for tune-ups in that same week. So the hint they gave us is that we should proceed to work from known to unknown using either the variance formulas or by using the columnar format as shown in Exhibit 10.6 and that we talked about in notes. I'm going to lay out that column format to get us thinking about the different components to consider and where these things sort of fit in that analysis. So if we think about the column format, we always had our actual results in the far left. And if we're thinking of labor, we'd say, well, this is our actual hours times our actual rate. In the middle-ish, we had our as-if budget, and that was our actual hours times our standard rate. And then over on the far right, we had our standards, or what would amount to our flex budget. That's our standard hours and our standard rate. Now let's also think about where these variances fall. So the labor rate variance is going to be, again, just the difference caused by a difference in rate only, not necessarily in usage of labor time in any way. So the rate variance is going to be over on this side. So let's just stick that in, 150 favorable, and that's our rate variance. And let's also make sure we think for a second about what that means. My total spend on labor for tune-ups was $150 less than it should have been, if you will, given what rate I actually paid for that stuff, for that labor. So in other words, my rate's got to be something less than that standard rate of $25. And I'm isolating it over here, and we've said that it's $150 favorable. We also know that the spending variance is $200, and that's unfavorable. And here I would just encourage you to be careful in terms of thinking of your levels of variance. That spending variance is the higher level than our rate and efficiency variance, so it comes about from comparing the actual result all the way over to our standard from the flex budget amount. So I'm going to jot that down here. $200 unfavorable, and that's our spending variance. Since that's unfavorable, we know that the actual spend has got to be greater than what would show up here in the flex. Now we also know everything about our standards: standard hours, standard rate, standard cost in total. So what we can start with is finding that amount that would be in, what equates to the flex budget over here. Want to make sure we're thinking about the actual level of output, so the 50 tune-ups. 50 tune-ups times the 2.5 hours they should take per tune-up would get our standard hours for our actual level of activity. And then if I multiplied that by my standard rate of $25, I could get my total expected cost here from the flex. We also could take the 50 tune-ups times that total standard cost of $62.50. Same thing. $3,125. Now again, working from our knowns to unknowns, we had already determined that the spending variance, or we were told I should say, was $200 unfavorable. So my actual spend would be the $3,125 from the flex, everything based on standard, plus $200, that unfavorable spending variance, $3,325. We can also go ahead and find the as-if amount, because we know that the rate variance was $150 favorable. So if we take the 3,325 from the actual and add the $150 favorable rate variance, we know that the as-if must have been 3,475. Now, though it didn't ask specifically for this, but I do want to go ahead and determine what the efficiency variance must have been, given that we've now backed into our as-if budget amount. So if I subtract the 3,475 from the as-if minus the 3,125 in the flex, we know our efficiency variance is $350. Since the as if is greater than the flex, that's got to be an unfavorable efficiency variance. We also could have found that by determining the difference between the overall spending variance and that favorable rate variance. Because remember, these two variances have to net out to equal our spending variance. And we can see that here. 350 unfavorable, 150 favorable, the net is 200 unfavorable. Getting back to the problem though, our first requirement was to determine the number of actual labor hours spent on tune-ups. So we can do that a couple different ways. We know that here in our as-if, that 3475 represents the actual hours, which is what we're looking for, times the standard rate. And we know the standard rate is $25. So I'm actually going to do this down here. The 3475 then, divided by the $25 standard rate, means the actual hours must have been 139. And just to be explicit, we're saying that 3475 would have to equal our unknown actual hours times our standard rate of $25 per hour. And then we just solved for the AH here. The 3475 divided by the $25, and there's our 139 actual hours. Next, we're looking for the actual hourly rate of pay for tune-ups. So over here in our actual results, we know that the actual hours that we now know times the actual rate have to equal 3,325. So down here we're saying 3,325 equals the 139 actual hours times that unknown actual rate, and we'll back solve for that actual rate. 3,325 divided by the 139 actual hours, and there's our rate of $23.92 rounded off. Actual rate. Now let's just compare these things to our variances and just make sure they make intuitive sense in terms of the direction of our variances. We had a $150 favorable rate variance. That means we paid less per hour than we expected to. The standard rate was $25, so my actual rate's got to be something less than $25. Well, yeah, it was. $23.92. That makes some sense. Similar idea over here in efficiency. My efficiency variance was unfavorable, so I needed more labor hours than I thought I should have. My actual hours used were 139. My standard hours, we didn't do this number separately, but it would have been the 50 tune-ups times the 2.5 standard hours per tune-up, or 125. So yeah, I used more hours than I thought I should have. That makes sense for an unfavorable efficiency variance. And that's it for exercise 10.5. Okay, the last problem I'm going to work through for now is actually part of a problem from your Chapter 10 homework. So in your Connect homework module, this is question 15, and we're going to at least work through the materials variances just to make sure we talk about a few considerations here. So the setup said Marvel Parts makes auto accessories. One of their products is seat covers that can be adjusted to fit a whole bunch of different cars. They use a standard cost system. According to standards, the factory should work 2,850 hours each month to produce 1,900 sets of covers. The standard costs associated with that level of production are shown here. So direct materials $22.40 per set, direct labor $27 per set, variable overhead based on labor hours $3.60 per set. During August, we know that the factory worked only 2,800 hours and produced 2,000 sets of covers. So right there, I'm just going to pause to make sure we're clear. That's a different level of actual output compared to what was expected here of 1,900 sets of covers. So we're going to make sure we need to account for that difference. The following actual costs were recorded during that same month. So here's direct materials, 12,000 yards, $22.80 per set of covers. direct labor 2450%, and variable overhead 350%. We also know that at standard, each set of covers should require 5.6 yards of material. All the materials purchased during the month were used in production. So the first thing we're going to do is come up with the materials price and quantity variances for August. So I'm going to think about our sort of column approach to these overall variances. Remember, we had the actual results on the far left, we had our as if in the middle, and then we had our flex, our standards on the far right. And for thinking about materials, this actual is our actual quantity times our actual price. As if is our actual quantity but times our standard price. And then our flex or standards are standard by standard. Standard quantity and standard price. I'm also going to just remind us in writing here, we need to consider our actual level of output. And here we're told that was 2,000 sets of covers. That's a little bit different than the expected level of 1,900 sets of covers. So let's think about our standards first. We want to incorporate our standard quantity and our standard price for materials, and we want to make sure we account for the actual level of output. So first, let's take a quick look at our standards and make sure we're clear on what this stuff should cost. And I'll kind of do some scratch work down here. We know that the total direct materials expected at our planned level of activity are $42,560, and that's $22.40 per set of covers. We also know that each set, though, should take 5.6 yards of material. So what we're saying is this $22.40 per set divided by the 5.6 yards of material that should be required per set means our standard rate, or standard price, excuse me, is $4 per yard. So a nice even $4. So we always want to make sure we're careful that we're not just incorporating the actual level of output when we're considering our different columns in our column approach, but also that we've accounted for the differences in standards in terms of quantity versus price. So now we can come up with our flex total over here. We've got our standard quantity of 5.6 yards of material per set of covers times our standard price of $4 per yard, and then we just want to make sure we multiply that times our actual output of the 2,000 sets of covers. So there's a grand total of $44,800. Now let's think about our actual spend. So it told us down here during August we had worked 2,800 labor hours, produced the 2,000 sets of covers, and our actual costs are just given in total. So the direct materials, 12,000 yards were actually purchased and used, and the total cost was $45,600. So I can already jot in that $45,600 total spend under the actual column. I don't necessarily have to consider the actual quantity and actual price separately yet. I am going to need to consider that though a bit when I get to my as if. So we were told again that the direct materials in total used were 12,000 yards. So that's my actual quantity. I don't have to consider the output separately because I know what the actual amount of the input used was. 12,000 yards times a standard price of $4 per yard that we'd calculated at the very beginning would mean a total of $48,000. So now I have enough to consider or to calculate all of my materials variances. So starting over on this side, if I take my $48,000 from the as if minus the $45,600 in the actual, I get a variance of $2,400. The actual spend was less than the as if, so we know that's a favorable price variance. Over here on this side, we'll take the $48,000 in the as if minus that $44,800 in the flex, for a difference of $3,200. Now the as-if is greater than the flex, so we'd say that's an unfavorable variance. And again, this represents our quantity variance. Now let's remind ourselves what these things mean. $2,400 favorable price variance, that means we paid less per yard than our $4 standard price. And just to be clear, we can see that in our actual spend down here. We spent a total of $45,600, and that was for 12,000 yards, $3.80 per yard. So yeah, that's less than our standard of $4, so that difference makes some sense. Over here on this side, we had a $3,200 unfavorable quantity variance. So we know that we used more material than we thought we should have compared to our standard of 5.6 yards per set. And we can do that math here as well. So 12,000 yards were used up to make 2,000 sets of covers. So that's 6 yards per set. Our standard was 5.6 yards, so we've used more than we thought we should, and that fits with our unfavorable quantity variance. Now the problem doesn't ask for this, but let's also go ahead and figure out what our overall spending variance for materials would be in this particular period. Remember, that comes about from the difference between our actual, our $45,600 in this case, minus our everything at standard from our flex, our $44,800, for a grand total of $800. Actual is greater than flex, so that's unfavorable. We also could find that by netting out the two lower level variances. $2,400 favorable price variance combined with a $3,200 unfavorable quantity variance, and there's an $800 unfavorable overall spending variance. So go ahead and try the labor and variable variances for this same problem, and of course let me know if you have any questions.